Whoa, look, here we are. It's time for the show. It's me, JP. It's time for JP's product pick of the week, so I'm doing it. That's what that means. And welcome to everyone from our chats. Thanks for stopping by over in YouTube land. We've got Jeff Hunt there, and thanks for copy editing my title of the YouTube, which was set to yesterday. What is time? Hey, Zoe Sherry, and in our Discord chat, that's this place right here, and that's where you can go if you're somewhere else. If you're over on Twitch or somewhere and you're wondering where the chat is, you could do worse than to check this out right here. This is Adafruit's Discord. If you don't know about it, it's at adafru.it. That's adafru with the u.it/Discord. You'll get an instantaneous invite to our Discord server, and then you just need to look for that right there. Live broadcast chat channel. Can you tell that I don't have my display mirrored here? I'm always confused about which side to point at. But that right there is our channel for use during live streaming, so that's a great place to come and hang out. Hello, Debo Dog and Blitz City DIY. Hey, Liz, nice to see you. Starman, Jim Hendrickson, C. Grover, thank you. Thanks for popping by. And we got a fun little product here today. So what happens? What happens here is I show you a new product, and I give you a big 50% discount on it. You'll just head over here. That's the URL or the QR code, depending on your preference. And if you head on over there, you'll see that we've got today's product pick slashed in half. The price is slashed in half, but the product is not. It is intact. So if you order yourself one or up to 10 of them, no resellers allowed, you'll get these in a timely fashion, hopefully, for a great discount. So head on over there. Before I talk about it, I like to go back just a little bit in time to have Lady Ada give us her new segment on the product, and then I'll do a little bit of a demo. I got a couple of demos for this one. So let's have Lady Ada take it away right now.
Okay. Another request, a lot of requests, but hey, if you email us and ask for something, there's a good chance I'll make it for you. We had some folks email and say they wanted like something that could simulate a PC fan. So it would generate a 100 hertz signal that you could then plug into your computer, and it would think that you had a fan. So if you're using water cooling or oil cooling, it wouldn't be like angry that you didn't have a fan connected. And I was like, oh, well, like having a general purpose PWM generator is not a bad idea. Go to our friend, the 555, and spun this together. So it's got a JST-PH connector, so you can just plug and play, or you can solder wires to the pins on the bottom there if you'd like. Provide it with 3 to 12 volt DC, and then you can select the range from about 15 to 250 hertz with the switches on the left, or 1.3 to 25 kilohertz if the switch is on the right, so kind of low frequency, high frequency. And then the fine frequency adjust, you twist the little potentiometer in the middle, and then you've got a nice solid square PWM output with a buffer, so you can use it to drive LEDs or even a small speaker if you wish. And then there's a signal LED to let you know, it pulses with the signal. Of course, it's at high frequencies, you're not going to see it. And an on LED. I thought I would show a quick demo. So this is it at the lower frequencies. So I twisted this all the way down, and you can actually see the this flickering. I mean, it's even to me, but of course the camera is picking it up a little funky. But it's flickering at about 14 hertz or so. And then as you twist it, it gets faster and faster and faster until it reaches about 250 hertz, which is the max. If you see on the left here, 250 is the maximum over here. If you flip the switch to the right, it changes the capacitor, and now you're up to 25 kilohertz. You can see the little K there, or you can turn all the way down to about 1.4, 1.5 hertz, kilohertz. So, kilohertz range on the right, hertz range on the left. So it could be good for, like this person wanted, simulating a PWM fan tachometer output. But also if you just need like a square wave or like, testing some audio stuff and you want like a 10 kilohertz square wave just to see like what, are you getting an audio path or something, or maybe modulating an LED? I don't know. I think like a general purpose PWM maker. Anyways, so this is a 555 timer STEMMA board.
Yes, it is. That's it indeed. Look, which way is right side up with that? This is my product pick of the week this week. It is the 555 PWM output STEMMA. So this gives you a couple of selectable ranges for your square wave output. It has a nice STEMMA connector so that you can get power ground and then the outgoing signal. And we have the little potentiometer built right on there that you can turn with a small screwdriver to dial in the particular frequency that you want. You can also use the header pins on there if you want to solder it into a project. But it's super, super convenient to get a nice square wave when you need one. So first of all, let's check out, here's the product page for this. So this is product ID 5963. And this is slashed in half. It's $1.98 right now. I think we sell some old stock of just 555 timer chips for about $4. So this thing's a bargain just for getting all of the accompanying circuitry built onto it. It's so easy. You don't have to breadboard a whole circuit to use a 555 timer. But right now, $1.98, amazing deal. So you can grab a handful of these if you want. And also listed on here, we have a couple of the different types of cables that you might want. That's a nice one if you want to go into breadboards with. I got some of these right here to be able to just plug onto the fan header pins on a motherboard. And I'll show you a demo of how that works in a moment. But if you take a little look here, you'll see, first of all, this show is being broadcast from inside that very page, so you can watch it right inside of there. I can't because black hole. But if we scroll on down past that dangerous video and click on Primary Guide, Adafruit 555 PWM Output STEMMA, you'll see this lovely guide that Liz Clark put together. Thank you, Liz. And this will take you through the basics of it, including its origins, as Lady Ada mentioned, as a PC fan dummy for cases where you need to fool your PC into thinking that you've got a fan connected to it because you're using something like liquid cooling. When you want a silent computer, you don't want fans running, but some motherboards and certain BIOS combinations just won't let you get away with that. They really want a fan on there. So this is a very inexpensive and simple way to tell the motherboard that there's a fan, because those fans have a little Hall effect sensor on them that just sends out a pulse every rotation of the fan blade spinning. And so we're going to fake that pulse with this, just a venerable 555 timer. If you scroll down a little further here, you'll see we've got a link to the pinouts page that will show you what you need to know about connecting it up, as well as you can get rid of the on LED and the signal LED by clipping these little jumper pads on the back there. And this mentions that this has a input voltage from anywhere from 3 volts DC to 12 volts DC, which is super convenient because you very often can grab 12 volts off of a PC motherboard. That's what a lot of the components on the PC motherboard are going to give you. But you can run it at anywhere from 3 to 5, and it's going to send out a maximum of 5 volts on that PWM pulse signal. So don't worry, you're not going to send out some giant 12-volt pulse. It's going to be a 5-volt pulse as far as your PC is concerned, and that's what it's expecting to trick the speed management software and hardware in there. So there's, as we've mentioned before, a couple of discrete ranges on here. So you can go anywhere from 1.5 hertz to 250 hertz in the low range, or flip this little switch here and go into the high range, and that will take you from 1.5 kilohertz to 25 kilohertz range. And then to dial in the specifics, you're going to use that little dial there. In fact, let me switch to a downshooter here, and we will take a little look. So what I've got here are a couple of these, and I've plugged them into a breadboard that's over here, and you can see I put a momentary switch on here. So I can run that through a little amplified speaker. It's Jaws. So these two are tuned to similar, but not quite the same frequency. And I'm also running a little pocket oscilloscope here so we can see the square wave coming off of here. So this is a 0 to 5 volt. It's positive only, it's not AC. And now what I'm going to do is I'm going to take a screwdriver here and adjust the frequency of this first timer. Got to wake up my speaker, hold on. And so that's actually down in the 1.5 hertz range. So 1.5 clicks a second there. So that's the range on the lower side, and then if I flip the switch, it's going to go way high. It's going to call the dogs. So those are the ranges you have. It could be musically interesting depending on what you're doing. You can also, with the two of them playing, we can tune one and leave the other alone, which is fun. So it's impossible to get them exactly in tune, but you'll get some of those nice beating frequencies of just barely being out of tune. So that's one use of 555 timers, and if you've ever run across things like Atari Punk consoles and some of the Forrest Mims books on making music, chiptune-y kind of music using 555 timers, this is useful for that. But what I want to show in the overhead camera over here, so let me switch things up a little bit, is so I've got a PC sitting on my workbench right there, big old PC, and you can see there it's got some fancy flashing RAM. Those little LEDs are the RAM sticks, amazing. And right here I've got my little 555 timer, and it is plugged into the power and ground and tachometer reader or speed reader pins on the motherboard for the system fan. So this is running right now, and I've booted it into its BIOS, the basic input-output system. I think that's what BIOS is. And since this motherboard has two 4-pin fan headers on it, one is actually still connected to the CPU because I don't, in fact, have water cooling on this, so I don't want to fry that. But since I have it open up and the AC running in here, I have essentially disconnected the case fan, the system fan. It's a littler fan back here. But you'll notice no alarm, right? Normally, if you disconnect the fan on this type of motherboard, you're going to get an alarm. It's going to tell you, hey, don't do this. It might even shut itself down because it's noticed that fan isn't running. But in this case, that fan is totally unplugged. But you can see here on my little BIOS readout, it says the current system fan speed is 1,155 RPM. Amazing, there is no fan plugged in, and that is because this little 555 timer is plugged right into there. So if I come over here and turn, where's my readout? Okay, I'm going to turn the little screw there. You'll see I'm essentially fooling the BIOS into thinking we have the fan running down in the 700 RPM range, or I can start to turn that back up into the 1,000 range. This is roughly what it wants. You can see the CPU fan is also running in this range, 1,200 or so RPM. It won't read in a crazy high range, so I'm not going to flip the switch on there. I think it'll just peg. But yeah, okay, here it thinks that this is an 8,500 RPM system fan, which would be really loud. It would probably move the thing across the desk, across my workbench if it were going that fast. We'd be building a little airfoil swamp boat. So I'm going to bring that back down to a reasonable range. But you can see there, that's the original use that Lady Ada was building this from a request, which is a kind of a common problem. If you look at it around out there for people who are doing water cooling or oil cooling, They can't always tell their BIOS to accept the fact that there is no fan connected. So that's that in action there. It is perfectly happy to run. We could reboot this now into Windows, and we would get no alarms during that post power on system test. It would go, yep, thumbs up. We have a fan in there. In fact, we do not. We just have a lie. We have a 5 timer telling a lie, but that's kind of nice. So here it is. You can see that's a little close up there, and you can see it mentions the ranges that we have, tells you your pin out on the bottom, as well as the voltage in and voltage out. So kind of all the info you need right there. I will mention, if you take a look at my down shooter here, this is a pulse width modulation, but you can't modulate it further. It is a square. So it is 50% duty cycle, on, off, on, off. We can't change that, so as I adjust the frequency, we're just going to continue to see a square wave. We're not able to change that duty to essentially adjust the sound, or if you're driving something like a little servo or something with it, you will be limited in what you can do with it. So it is pulse width modulated to a 50% duty cycle. No changing that. So you will not be making an Atari Punk console with these, at least without some additional circuitry and work. But that is the basics of this. It's straightforward. There's no software. This is just plug and play and go, and then tune it to your needs. So let's see, are there any questions over in the chats? Looks like no. Yeah, this one's straightforward. So go grab one if you want. That's the URL right there. You can go pick some up until the end of the show. Somewhere in the next 10 minutes or so, the price will go back up. They're not expensive anyway, so normally about $4. Right now, about $1 and 98 cents, actually exactly $1.98. Pick some up and pick up some cables to go with them, and do some fun PWM stuff. This also, as Lady Ada said, satisfies the gatekeeping portion of the internet that thinks that you shouldn't use an Arduino for anything, and you can just do it all with a 555 timer. So have a 555 timer in your kit. Maybe it'll do what you want. So I think that is going to do it for today. Thanks everyone for stopping by, and let's close this out. So that right there is my product pick of the week this week. It is the 555 PWM output STEMMA. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week, and I will see you next time. Bye-bye.